Starting with the name of Allah, who is most merciful and most beneficent. Today we are here to present our Parser. Our group members are Ghias Ali Raza, Mohammad Abdul Haq, and myself, Mohammad Bilal. Before starting the presentation, we would like to give you a demo of our project. Ghias Ali will show you the demo of our project. We will show you by inserting an input, and we will also show you the output of the project, and we will explain the each step. Ghias Ali, please start.
So now let us check the input for our program. So this is operator precedence parser. So of course this will accept the pattern of the string which will match the uh, expression of the parser like operator precedence. So let's suppose I am giving the input of n, p, n, m, n dollar. Here p is for plus showing and m is for multiplication showing. So and dollar shows that the expression of the end. Now we can see that this is our intermediate code. P has been changed to plus and M has been changed to static, and dollar is also removed. So this is our intermediate code, and lexeme are also produced. Here is showing. This is the parsing table of our grammar, and now this is the shift and reduce operation. Now let us check for the some other operation that it will properly show the error of input. For example, I am giving input like a NNP, which is obviously incorrect input, and our grammar parser should have to give the error for this input. Now we can see that here is showing that the parser encountered problem while parsing the input. So this shows that our parser has also maintaining the syntax of the error. If we give the incorrect syntax, then the parser will show it. Now let us move towards the slide how this will performed by the code. Now this is the input of our code as we have seen in the grammar project demo, that we can input in expression of the type of the expression we have operand and operator, and this is the intermediate code generation for our input. So the any expression which have been mm, in between the plus p or m sign, which is for the plus or multiplication, will be converted into plus or minus, which is of the form of the arithmetic expression. So this is the intermediate code generation, as we have seen that, for example, if we have n plus n dollar expressions and or np and dollar expressions, so np and dollar expression, so it will be converted into n plus n as intermediate code. So now the next part will be explained by Mr. Ali Raza.
So, as Mr. Ghias has told you about the intermediate code generation, now we'll take a look at lexemes and tokenization. So this is our code for generating lexemes and tokenization. As you can see, we have made an object of hash map. So, and in the second line, we are storing the operators in a character array called operators P and M. P is for plus and M is for multiplication. I request Mr. Ghias to move his cursor on the screen as I am explaining that part of the code. So, and string expression equal to uh, the inverted commas plus input. In the expression, we are storing our input, and then we are making an object of string tokenizer, and then let's come on to the while loop. And as you can see that in if condition, we are telling that expression dot char at z equal to operators of 0, which means that if we come across the operator p, which means plus, in the expression, or we come across the operator m, in this case operators of index 1, then put it in the symbol table with the string named operator. As you can see, sim tab dot put operator. We have the code here. So it will be treated as an operator, and if not, if we don't come across an operator, obviously we will have the term. So it will jump into the else expression, and we will put that term in the symbol table, but this time we will put it with the string name term so that we can differentiate between operator and term. And at last we are printing the lexeme. As you can see, system.out.println lexeme symbol table. So now let's go further and see about what our grammar is, what is the rules and what it is doing. So talking about our grammar, as you can see, S produces E produces EPT or TP as we discussed before, P for plus, T produces TMF or FM for multiplication, and at last F produces E or N. So what our grammar is doing, it is simply adding or multiplying two terms, as you can see from the grammar rules. So now let's take a look at the terminals, how terminals are being stored, and initialization of the parse table. Initialization of the parse table array. So as we can see, string builder SB equal to new string builder. We are making an object of string builder type, which is not so different from the string. So, and we are storing the grammar rules in it. And after that, as you can see in the loop, what we are doing, we are storing the terminals. And if you can see on the if condition, the dollar, the parentheses, MPN, they are all the terminals of our grammar, and we are storing it into uh, terminal variable. And after that, we are making an array of parse table of name parse table, which is of size terminal dot size plus one. Now we are making it terminals of size plus one because uh, if we see at the next slide, next slide, which will be explained by Mr. Bilal, but let me show you why is it plus one. So here, if we see this 0, comma 0 index is empty. So for that, we have to initialize it as plus one. Now over to you, Mr. Bilal.
So here is the parser table initialization code, and on the left it is the code, and on the right it is the uh, an image. It is not the output of the code, but demonstrate you visual representation. I have attached this picture. So from the code you can see there are four loops, two nested loops, and we are generating the terminals on the table. We are generating the terminals on the left and top, such as P dollar bracket signs M and N. M represents the plus sign, and M represents the multiply sign, and P represents the plus sign as stored by Ghias. There are two for loops, also two nested loops, which are initializing and assigning values for the variables, which you can see on the table. Next slide. So this is parse table generator. As we have seen, we have initialized the terminals on the table. Now to display all the precedence on the table, we have created this parse table generator, and this is in this code we are just telling which terminal has higher precedence than another variable, and which terminal has lower precedence on with respect to another terminal. Next slide. The parser code, and this is the parser code, and it is will be explained by Mohammed Abdullah.
Here we are going to parse our string. If there comes the $n in the stack and dollar at the input, our string will be accepted. Whereas during the parsing, if the character at the input has higher precedence than the character present in the stack, then our character will be shifted, as we can see the shift code on the screen. And if the character at the input has less precedence than the character present in the stack, then our character will be reduced. Please next slide. As we can see the reduced code on the screen. And if there comes any character out of our parse table, then there will be a syntax error. That's all from my side. Thank you.